The first unit of first block is completed. Now we are coming on second unit of first block. This is for processes. We discuss in this the concept of process, implicit and explicit tasking, processes, relationship, process states, implementation of processes, process hierarchy, threads, level of threads, system call for process management, and process scheduling. What is process? Before starting all topics and number of topics, we must know what is process. Process is a procedure or is a kind of task which contains the number of steps, number of sequence of tasks which is used for completion or execution a particular job. Process is a kind of procedure for completion the particular task by following some number of steps. That's all. You can define the process, and the definition is coming into the next slides. Now come to the next topics. These are the scheduling algorithms which we discuss in this unit. First come first serve. In this number of jobs are there, but we will execute that jobs on the basis of which first come first serve basis. Either it will take less time or greater time as compared to other processes for execution. Shortest job first. In this we execute only that task first which takes the lesser time as compared to the other task. Round robin is the scheduling algorithm, and you can say time sharing algorithm, which help number of processes can work together by switching after some time quantum. Now let's start with process. A program is a passive, a process is active. What is the difference between passive and active? Program is passive in such a manner process is active, because program initiate the process. It is not directly execute, but process participating in the execution or in the completion of jobs actively. A process is getting started whenever the system is turning on, but a program is started whenever we require a kind of application, a particular specific application software, an instance of program in execution, you can say. Now, attribute held by a process include hardware state. It is in idle state or in executing some process or in engage in doing some manual task. Next is memory, which is required for storing the mediator results, intermediary results, or final outputs, final results. Next one is CPU, for processing the task, for completion, for controlling, for performing arithmetical logical operations using ALU, providing control using CU, and all that kind of units or devices installed in the CPU. Next one is progress. Progress representing the how much task, how much job is completed and how much is remaining. Now, why have processes? Why we have number of processes for completion of our task, like resource sharing that help us to share data, files, logical files and physical devices by using networking, like a single printer will be installed in n number of computers, or you can say 20 computers, and every computer is able to give command to that particular single printer by using networks that representing the physical hardware resource sharing. In logical way, a single memory is installed for n number of processors or n number of multitasking operating systems. The next one is computation speed up. taking advantage of multi-programming, example of a customer server database system. Next one is modularity for production, like there is a complex task or critical task is there that should be break down in number of structures, number of jobs, and that represents the modularity for productions. Next is implicit and explicit tasking. Implicit tasking means that processes are defined by the system. It is commonly encountered in general purpose multi-programming system. Now, processes created in this manner are usually transient in the sense that they are destroyed and disposed of by the system after each run. Some tasks and some files are not required or are not much longer required after completion of the task. Then the garbage collection or transient process is started by the operating system for removing that kind of unwanted or unused files which are not longer required in future. This is the implicit tasking. And explicit tasking, whenever we are going to delete some unwanted files, unwanted images, unwanted content, whichever is not required in future, that is explicit tasking. Whenever we are doing any task manually, that is the explicit tasking. The tasks which are done by the operating system automatically or after time slot, that is the implicit tasking. Explicit tasking means that program explicitly define each process and some of its attribute. To improve the performance, a single logical application is divided into various related processes. Explicit tasking is used in situations where high performance in desired system programs. Is that clear? Reasons for and uses of explicit tasking. First, speed up. To increase the system speed up, we are not going to be wait whenever system is going to clear the temporary memory, clear the buffer. We are going to be execute memory cleaner, defragmenter, for content analyzer, for speed up the contents, for speed up the process. Second one, driving input output devices that have latency. We are going to be apply the input output devices which are taking so much time. We are going to be replace that kind of devices. We are going to be detached that devices for increasing their speed if they are not responding according to our requirement and according to our processes. The next one is user convenience. All the devices and applications or the softwares or the operating system are installed in particular devices, in particular machines according to the user requirement or convenient, where user can interact easily and do their task comfortably. Next one is multiprocessing and multi-computing. As we discussed earlier, multiprocessing, number of processors are there where number of users can execute their task, and multi-computing for computing the number of critical tasks, for apply the calculations, for performing their operations on system for generating the results. Next is process relationship. There are basically two types of relationship exist between two processes. First, competition. In the concurrent environment, processes compete with each other for allocation of system resource to execute their instructions. Suppose we are having number of processes, or we can say P1, P2, P3 processes. They are going to execute in single operating system and requesting for resources. They are generating some same time synchronization where they can access the data, they can use the data for generating the exact or required results or approve their efficiency by the operating system. That is the competition between the processes for completion their task, and that can be proper resource allocation and protection in address generation. Next one is cooperation. Whenever there is multiple processors are there, they are executing number of tasks. If any processor is not working, then that load or that processor work is contributed by the other remaining processors for completing their task or execution. A collection of related processes that collectively represent a single logical application cooperate with each other. Now the next one is difference between independent process and cooperating process. This is as like a single person doing their task in a whole day, and if we are putting more than one person for the same task, they can complete that task within 2 or 3 hours. A single person is completing that particular task in 10 hours, 12 hours, but we are providing some n number of persons or more than one person for that particular task. That task can be completed before the time, or as compared to single person lesser in time. This is the difference between the independent process and cooperating process. In independent process, the state of independent process is not shared in any way by any process. Their execution is deterministic. The result of execution depend only on the input value, how much effort, how much resources are available on time, how much processing time is taken by the operating system. That all constraints are applied on independent process, but in cooperating process can affect or be affected by other process executing the system. They are characterized by their states are shared by other processes. Also, as I am discussing the example, a single person is doing the task for a whole day, and more than one person can do the same task in lesser time as compared to a single person. Their execution is not deterministic. The result of execution depend on relative execution of other sequence, and processes cannot be predicted in advance. Now come to the next. These are the process states which comes in the execution, or which used by a process for completion their task. First, a new state, then running, waiting, readying, and suspended. These are the states. New state, whenever a new process is entering in a system for execution, and that thing is much clear with this diagram. Now, this is the new process when entering into the system for execution, that is admitted and ready for execution. This is the, you can say, before starting the execution state. After ready, it can go for the running state. Every new process which enter into the system come into the new state, then ready state, and from ready state it can directly go for running or execution. And it can be interrupted, and there is the possibility in the running state, if higher priority task will come, the running task or the executing process can go for and can go for waiting state, and that will come from here to waiting state, and the high priority task will execute and get terminated or exited from the system. Then again this process or this task which is just coming from the running state to waiting state can go or have to go in ready state and follow the same process from ready state to running state, and if it is interrupted, it may come into the ready state or it may come into the waiting for input output. And in this state, if higher priority task will come, if there is no any kind of interruption will come, the process will smoothly get executed and completed and exited from the system, and it will get terminated. If there is any kind of interrupt will occur, if high priority interrupt occur, then the process will come in ready state from running state. If the input output event wait or kind of interrupt will occur, the process will come from running state to waiting state, and it is the very much longer, or it is it taking so much time, then the process will come from waiting state to ready state and have to follow the same sequence or process for completion their tasks. Welcome to VLearn. Now we'll continue from the last class. In the last class we discussed about the process states, like a new process will enter from these steps followed by the new state, ready state. It will goes from ready to running state, then from running state to terminated. If there is no any interrupt will occur. If there is any kind of problem or interrupt will occur or higher priority interrupt will enter into the system, then it will interrupted from the running state, and the process which interrupted will come into the waiting state, and if it takes some longer time, then the process from waiting state will come into the ready state. After ready state, it follows the same process as like it execute the process and enter into the running state. If there is no any interruption will occur, the process will smoothly goes into exit state or terminate state. Now come to the next slide, because the last topic we discussed in the last class, implementation of processes. Implementation of processes represent how we interact the system using some process, how process will interpret the processes which are entered by the user, or number of process executes inside the system, and it has the number of registers, number of PCB, control unit, CPU, PC, or another number of registers. Like in front of our screen, we are having a diagram which contains the pointer, which represent the block pointer, in which block we are working. Next represent the process state, in which process state we are having right now, and in which process state we are executing our process. As we discussed in the previous slide, there is the number of states are there, in which state process is currently or at the run time, and in which state it is going to be executed, and after that state it will go into the next state, or will go into the again waiting state, or then ready state. These are a kind of states which represent the processes states. In the process number, it represents the in which sequence our process is going to be executed, and is going to be in a program counter, and the program counter represent the how much program executed, or how much times we are going to be execute a same program or a sequence number, and the process which are inside the control unit controlling by the CPU, and control unit provide the number of resources which are required for execution of process. Then we have the registers. Registers store the data in a temporary format which are required to store intermediary files, intermediary results. Registers are the temporary storage which hold the data for some time or for the execution process. After the completion of execution or completion of the process, that memory will be get reallocated to the next process or to the next execution process. Now next is the memory limits. We can allocate any memory, we can allocate any resource to a register, to a process, in that manner to utilization of any resource for efficiency of the system. And we have to implement the efficient utilization of available resources. By that way we can utilize maximum resource, maximum memory, maximum resources for execution of the processes. Next one is list of open files. List of open files represent the indexing or offset of the memory, which number of processes executing, or which number of processes locating at what location, and from that location how the process will get retrieved for the further processing or for the further executions. Now it is shows in the left side there is a data structure holding by the process control block, like PC represent the program counter, CPU represent CPU central processing unit, registers which store the data or processing the data for a duration or for some session. Next one is memory management information, that memory is managed by the control unit or memory managed by the memory MMU or direct memory access for providing the fast accessing data. Memory management information contains the information how much memory we have and how much memory is used by the processor which is executing currently and how much memory already allocated to the number of processes. It have the kind of storage capacity to store the information or creating offset. Offset represent the indexes. Next one is accounting. Time used and ID. It store or it can create some kind of log in which it store the information about the user or about the process, which process taken, how much time, how much resources allocated that particular process, and how much efficiently that is executed, and how much it works for us efficiently and for the processes and giving the correct results. Next one is representing input output status. Input output status we have in number of states like valid input, invalid output. We have the number of combination: valid input, invalid output, invalid input, valid output, valid input, invalid output. If we are having a right combination like valid input, valid output, invalid input, invalid output, this is the best combination for input output status of the process. By that way we can achieve the efficiency, or we can say we can achieve the efficiently execution process at the runtime. And the next is scheduling data. Scheduling data representing the resource or process to schedule at that manner by which we can use efficiently every resource, and no process can sit or can stay idle and cannot be wait for the longer time. If any process goes to the waiting state for a longer time, then it could be cause of the deadlock, and it have the single condition of deadlock. In deadlock we have the condition continuous waiting, and the process will goes into the waiting stage, that we can the cause of deadlock. Now next one is process state. In process state we already discussed the process in which state is going to be running, waiting, terminating, executing, and runnable. These are the process state in which state currently the process is going to be executed or going to be waiting state. Now next one is process number, in which sequence number the process is going to be executed, and the process have the unique numbers or represent their identities. Next one slide, context switching. Context switching represent the switching essentially the same as process switch. It means that the memory as seen by one process is changed to the memory seen by another process. Context switching represent like P1 resource executing a task, you can say P1 resource executing a job J1, and P2 process executing a job like J2. If they are switching to each other for sharing the resources or for executing their processes or jobs, then it represents the context switching. Means P1 process executing a job J1, P2 process executing job J2, and P3 process executing job J3. These jobs are executing simultaneously, but if the resources are required or need to be shared the resources by each other, they can context switch in between the processes. P1 can access the resource which is held by the P2 process, P2 process can access the resource held by the P3 process. These are the context switching done inside the processes. Scheduling, you can say scheduling is a process by means changing the active PCB control, process control block pointed to by the CPU. Scheduling represent the how much processes we have and which process should be executed first, which process should be given the how much time is required, how much time is allocated. The remaining time will be calculated in the next cycle. It represents the scheduling in a way like we schedule our programs, we schedule our daily routine task, that the same manner if we have the number of processes to be executed, we can schedule them and allocated a particular time quantum. After that time quantum, the schedule will go to the next, and after the recycling that the schedule there is the 4 processes P1, P2, P3, P4. Everyone required the 15 minutes, but we have the time quantum 5 minutes. After 5 minutes, that control will be transferred to the next process, and this process will continue till the processes get over their execution and over their process completion their task. Now scheduling queues. Scheduling queue represents some sequence of steps for execution. It can be much more clear with this example. Executing a process control block, there is the n number of blocks can be possible. Suppose we have executing a sequence from this P02 to the downward, and we are having the saved state into PCB0, PCB1, PCB1, PCB0. This is alternatively, this time will come and interrupt will occur, then the process will start from the previous job. Suppose this is the ideal execution of a process PCB0 and PCB1. This is there can be n number of processes is possible. If any interruption will come, the execution state will be break for some time. After that interrupt, the process will continue from the previous process and will continue to the next process. This cycle will completely repeated till the completion of the process execution or till the completion their task. Now this is the CPU switching from one process to another process. Suppose we are working on a computer and typing some content or typing some text into the Word file. We switch to multimedia for changing the song, then again switch to the Word file for typing the context. This representing the switching between the number of processes which are working or running simultaneously on the same system. Now come to the next. It represents the process hierarchy. A process may create several new processes during its time of execution. A single process can create number of processes, or can say number of new processes during its time of execution. This number of processes we can say the child processes, and the process which generate these processes is called the parent process. We can say the root process is called the parent process, and the process which are generated by the parent process is called the child processes. There are different possibilities concerning creating new processes like execution, for completion the task, for execution the states. Next is sharing, for resource sharing to execution or completion the process jobs. And now this is represent the process hierarchy. We can say A, B, C are the forks which are generated by the parents. Parent can run concurrently with child or wait for completion. Parent now child may shell, all, fork or join. These are commands for creating a new process or entering a new process for the execution state. Death of a parent may force death of a child. If any parent process is going to be executing and the same time a new interrupt will occur, and the new interrupt which is executing a process and going to be a longer time, the waiting process which is interrupted can be cause the death of their child processes as well. If the parent process waiting for so many times or so much time, the parent child process will also depend on the parent process. If this process will continue till the infinity times, and we cannot define how much time it will take much more or how much time is remaining for the waiting process, then it may cause of the death of the parent process. At the same time, the child process is also goes into the same state as the parent state. Come to the next. This is the process are static, never terminate, or dynamic, can terminate. If we have the static process, it cannot be terminated and it cannot be interruptible. So the parent process and child process cannot be goes in the state of death. If they are having the dynamic termination, in the dynamic termination, any new interrupt or any higher priority interrupt can interrupt the executing state of the existing process, and it can be the cause of infinity time waiting state of running process. Is that clear? Now, what is thread? Thread is a lightweight process. as the general meaning, thread is a small any part of anything, and thread can be lightweight. If we are having a program for arithmetic operations, in that we are having the functions like addition, subtraction, multiplication, division, all are independently like a thread, and if we combine all of these processes or all of these functions, it becomes a program. So thread is a lightweight program which is representing a single task which is executing independently and which can be executed by the linked process which call it itself. Thread simply enable us to split up a program into logically separate pieces and have the pieces run independently of one another until they need to communicate. As I just given the example, as we are having a arithmetic operation program, in that we are having number of functions like addition, subtraction, division, multiplication. If we required any one of process or any one of function, we can execute it independently. If required, it can be linked with the other process or other functions if required, but it can be also executed independently. So there is no any foundation on that particular process. It can execute with this function or this function. These are independently defined. So that is, we can say it is the thread which can execute independently, which is designed for the particular task. If that task is completed, the process is completed, thread job is completed. Now come to the next slide. Thread are cheaper than normal process, and that they can be scheduled for execution in a user dependent way with less overhead. Thread are not function dependent, they are user dependent. If user required any thread, he or she can execute that particular thread for their completion of requirement, for their completion of task, but any function is not dependent to any other function. They are independently work for the completion of their goals and their task. Now reason to use threads. Why we require that kind of threads? Thread allow a programmer to switch between lightweight processes. When it is best for the programmer has control. Thread, as I discussed thread representing the independent programs. If we write the complete program and we are not going to write a single thread, then it shows the overhead or overburden to the program or overburden to the programmer to design the every code which is not required for that particular task. A process which uses thread does not get more CPU time than an ordinary process. Any ordinary program or any ordinary functions takes so much time as compared to the thread. Thread takes so much lesser time as compared to the process because it is used for implementing a particular task or particular job. Now, inside a heavyweight process, thread are scheduled on a first come first served basis. Means as like a queue. If we come first, we making a queue at the first line at the front of the execution. Now we executed first and exit from the program first. So same, there is a way inside a heavyweight process, threads are scheduled on a first come first served basis unless the program decide to force certain thread to wait for other threads. Unless our requirement, a single thread is not going to be wait for the other thread. If it come first, it get executed first. We requirement the execution sequence one is executed after third process, then it is scheduled according to requirement. Otherwise it will executed on the first come first served basis. These are the level of thread. It represents first kernel level. In kernel level, the thread will executed or will process according to the CPU or to the system requirement. User level, at user level, thread is executed according to the user requirement, according to the user level or user layers. A kernel level thread behave like a virtual CPU or a power point to which user process can connect in order to get computing power, which represent the calculations which represent the execution process speed up. The kernel has a many system level threads as it has CPU, and each of these must be shared between all of the user thread, as we shared the resources for execution our task or completion of a task which is located or relocated at nearby our system or attached with our system devices. In other words, the maximum number of user level threads which can be active at any one time is equal to the number of system level thread, which in turn is equal to the number of CPU on the system. We can run or we can execute the number of threads at the same time. The number of system threads are equal to that, but which is required, the number of processor or number of CPU should be equal to the number of process or number of threads executed by the user as well as system, as well as the number of processes required by the CPU at the same time. Now, system calls for process management. These calls are initiated by a system, by a process for execution or completion their task. The first is the create. In response to the create call, operating system create a new process for a particular purpose, particular task, particular job. Next one is delete. The delete services is also called destroy, terminate or exit due to the interruption of any new process, due to the interruption of higher priority interrupt. Next one is abort. It is used to terminate the process forcibly. Means a process which is executing or which is going to be executing in a runnable state or running state should be called by itself of the system, and if any high priority interrupt will occur, it can also interrupt that process and get a exit from the terminate state if we have the higher priority interrupt in a waiting state. Next one is fork and join command. The fork operations are used to split a sequence of instruction into two concurrently executable sequences. Join is used to merge the two sequences if the two processes is going to be executed simultaneously for the same purpose. Now start with the from creating process. In create process, the system will call create command for starting a new process. For starting a new process with the specified or default attributes and additive files which are the required by the system or which are required by the processes, which is the needful memory, needful process, needful attributes are allocated by a system to creating a process or thread. Next one is delete. The delete service is also called destroy, terminate or exit. It represents if we are going to execute any process, if it is completed, then it will go to terminate or exit state. If we are having or a new process is coming which is very much high priority, then we are going to be destroy that running process or running job and execute the higher priority task. Then we'll call it again in a new sequence. Now abort. It is used to terminate the process forcibly. If there is any, it can be possibility we are having a higher priority interrupt, we are going to be executing or getting an output not according to our requirement, the job is not going to be right. In that case, we can forcibly abort any running process. Next one is fork and join. The fork operation are used to split a sequence of instruction into two concurrently executable sequences. It can represent the parallel execution. Join is used to merge the two sequences of code divided by the fork, which are equally representing the process state, equally representing the execution that can be joined. It is available to a parent process for synchronization with a child. Means if A process is running and it is having a B child, if A process is running at the same stage and B is also following that A stage, then they are synchronizing with each other. If A process is having some errors, then the B process is also get terminated or getting some errors. That's why both of them will go to the death state, as we discussed in this previous slide. So the fork operations are used to split a sequence, and join operation is used to merging the number of processes which are concurrently executing or simultaneously in the same state. If parent node having some error, then the same way child node also have some error. If there is any problem in the execution of parent node, that error will comes into the child node at the simultaneously. Now come to the next slide. Suspend. Suspend system call is also called block in some systems. The designated process is suspended indefinitely and placed in the suspended state. The suspend state is a state in which we suspend any process for infinite time, so that process goes into the suspend state and will call it again from the beginning as a new fresh process or as a new fresh job will come into the new state, then runnable state, then goes to running state, and if it is smoothly executed, then it goes to the terminate or exit state. Now system calls for process management. Resume. Resume system call is also called wake up in some system, like we are calling some process in suspended state, we can resume that process by forwarding a resume state. It will continue from the interrupted level or state. Next one is delay. The system called delay is also known as sleep state. The process will go for some short duration in a sleep state. It will get again wake up after that time period. Get attributes represent the process features, that identities, that attributes represent specified subset, their duration of execution, their process which are going to be executed inside that, and change priority represent it is an instance of more general set process attributes. System call. Obviously this call is not implemented in system where process priority is static. Is that clear? This topic is completed. We'll continue it